Welcome back. We're going to start a new unit, and this unit is very different than the units we've been working on before. Instead of solving and finding x, we're going to start talking about more of a conceptual idea called functions. And the first type of function we're going to talk about are discrete functions. You may have heard functions in middle school. We're going to expand on that, I think, in this lesson. So after this lesson, you should be able to determine what a relation is, whether that relationship is a function, and finding domain and range of these functions. And specifically, we're going to talk about discrete functions. But let's first start off with what a relation is. And a relation is, we're going to fill this out here. A relation is just a set of ordered pairs, an x and a y, where x is called the input and y is called the output. So if I have the coordinate pair 3, 7, 3 would be my input and 7 would be my output, okay? It's like we're looking for what the y is when we have the x. That's just a relation, very simple. When we describe a relationship, we can describe it usually using descriptors. You know, we're not just given a coordinate pair of numbers. Usually those numbers represent something. So in this example, this set of ordered pairs represent the ages and the heights of boys given in years and inches. So we're just looking at ages and heights and how they're related to each other. That's why they're called relations. So here's our set of ordered pairs. And what this means is that when this boy is 7 years old, his height is 35 inches. That's what that coordinate pair is saying. That's what all these coordinate pairs are saying. So is this a relation? Yeah, it's a relation. And we know that because it's a set of ordered pairs. We can also say that it has inputs and outputs. Okay. What are these input values? Well, the input values are going to be the x's. And they're going to be all of the ones I'm going to underline in red. So 7, 8, 9, 10. 10 is repeated. We're going to talk about what that is a little bit later. But when I put these down at 7, 8, 9, 10, we don't need to write the 10 twice. 11 and 12. And what do these represent? These represent something called the domain, which we're going to talk about in a little bit. What are the output values? Well, all the output values are the y's. So all of those inches, the heights. So those output values would be 35, 40. We don't need to repeat the 40, 45, 50, 55, and 60. And what do those represent? That represents something called the range. Okay. Essentially, the domain is your x values and your range is your y values. Okay. So let's talk about a specific type of a specific type of relation called discrete. So this lesson focuses on this concept of discrete relation. So a discrete relation is where the input and output consist of distinct and unconnected points. That's really the key here. They're unconnected. Okay. So that is what our goal is today, is to really talk about discrete relations. And I also mentioned something called domain and range. And so domain is all possible inputs, which are your x values. And we list those in something called set notation, which looks like these little curly brackets, okay? And your range is all your possible output values. And those are your y values. Those are also listed in set notation. And it's really important we use this set notation, these brackets in today's lesson, and in your practice. I'm going to be looking for the fact that you're using set notation. So if we go back to this part, we should put these input values in curly brackets, okay, to show that this is a set of all the values. And your curly brackets don't need to be perfect. They can be a little squiggle. My curly brackets are not always perfect looking, and sometimes they're a little challenging to write. So do your best. Ask if you need help with those. So here's what I'd like you to be able to do in today's lesson. I'd like you to be able to make a table, make a graph, make a mapping diagram, decide if something's discrete or not, and find the domain and range, which I know is a lot. So this example sort of covers all of that. So in example 1, here's a set of ordered pairs that represent the ages and heights. It's the same ordered pairs that we worked with before, but now we're going to use them to sort of describe more specifically what they look like in these different representations. So let's first create a table. So a table lists your x and y values, all of them. So my x values we already found. I'm going to underline them again in red. And your y values are what I'm underlining in this purple color. We already did that. So when we list something in a table, the first point is 735. The second point is 8, and I'm going to use a different color here. Is 735, 840, 940, 1045, 1050. Notice we're going to list that 10 twice in a table. 1155 and 1260. So now I've got a table of all these points. And now that I've got a table, I've got my coordinate pairs, I should be able to create a graph. When we plot coordinate pairs, we always do the x first and then the y. So 735, here's my 7 right there, and my 35 is right here. So I'm going to go over to the right 7, up to 35, and draw my coordinate pair. Okay. The next one is 840, so I'm going to go to 8 and go up to 40, make my next coordinate pair. 940, third coordinate pair. 1045, fourth coordinate pair. 1050, there's my fifth one. 1155, and 1260. So those are plotting coordinate pairs. We learned how to plot coordinate pairs probably in middle school. If you need help with this, please ask. I know sometimes that can be a challenge. So just if you want to pause the video now and ask how I plotted those points, please do so. I'm happy to help. A mapping diagram might be new. In a mapping diagram, we list all of our inputs in order from least to greatest. So 7, 8, 9, 10, 11, and 12. Notice that I did not repeat that 10. Even though it's repeated in the coordinate pairs, we only list that once in a mapping diagram. And then the heights, the y values, we're going to list also in least to greatest, 35, 40, 45, 50, 55, and 60. Notice that I only listed that 40 once. And now I'm going to connect them. That's the key with a mapping diagram. Connect the x to the y. So 7 goes to 35. I don't need to draw a little arrow. 8 goes to 40. 9 also goes to 40, so that line's going to go to 40 twice. 1045, 1155, and 1260. That's a mapping diagram. You list your x's, list your y's, and connect them. Least to greatest. Always least to greatest everywhere. In general. Is this a discrete relation? Yes. How do we know? Because all the points in our graph are unconnected. The domain is all of those x values listed in set notation. So there's my curly bracket, and my domain is going to be 7, 8, 9, 10, 11, and 12. Notice that we only list it once. The 10, I mean. And our range are all the y values. Use your set notation or curly bracket. 35, 40, 45, 50, 55, and 60. Notice again, I'm only listing that 40 once. I'm going to be looking for that when you do your practice and your mastery, okay? Okay, so this is a relation, a discrete relation. Okay, we're going to talk now about a specific type of relation called a function. So you may have heard of functions before, so let's define a function. And again, it's a specific type of relation. So it is a relation, like we just looked at, where each input has only one output, just one. It can't have two, can't have three, can't have four, only has one output. So we can also say that each x has only one y. That's another way we can think about it. So first, let's look at a function in coordinate pairs. Okay, so in a coordinate pair, let's underline all the x's. So 4 has a 7, 2 has a 1. All right, 4 has 7, 2 has a 1, 3 has a 6, and 3 has a 4. This is a function because each x has only one y. 4 has 7, it doesn't have another one. 2 has only 1, -3 has only 6, and 3 has only 4. That's a function. Then this next one, -1 has a 6, 1 has a 3, 2 has a 5, and then 1 has a 7 again. This is sort of an issue, these two, because 1 repeats. 1 has 3 and 7. That's an x value having two y values, so this is not a function. Okay. In the next one, I've got 1 having a 5, 2 having a 6, 3 having a 6, and 4 having a 7. Notice that the 6 and the 6 repeat. That is okay. So the y value repeating, that's all right. It's saying that 2 has a 6, 3 has a 6, so 2 and 3 each have a different y value. That is okay. So we can call this a function. So that's what functions look like in coordinate pairs. What does a function look like in a graph? A function in a graph, we can use something called the vertical line test. The vertical line test is where we can draw a vertical line Remember, a vertical line goes up and down. Okay, so we draw a vertical line, and it should never go through a point more than once. So if I draw a vertical line through each point, there's 1, 1, and 1. So those vertical lines only go through one point, so this is a function. On the second example, if I draw a vertical line through this, notice I hit a point here and I hit a point here. I don't even need to draw a line through the others because immediately I can say that is not a function because it goes through those two coordinate pairs twice. And what does a function look like in a mapping diagram? Well, I'm going to look at the x values. This is your x, this is your y. And I can see that 3 goes to 4, 5 goes to 4, 7 goes to 6. That's okay because it's okay for each x to have a one y value. So this number 4 here, that is okay. It's okay for having the outputs repeat. That's okay because each x has only one y. Even though that 3 and 5 have a 4, 3 has a 4, 5 has a 4, 3 and 5 are different. Okay. On the next example, I see 3 has 8, 5 has 4, and 7 has 6. Each input has only one output. Again, this is x and y, so this is a function. Okay, I should also note up here that this is a function. In our third example, I've got 3 doesn't go to 3 for some reason doesn't go to anything. We can say 3 goes to 8. Let's make it 3 goes to 8. That must have been a mistake on my part. 3 goes to 8. But notice that 5 goes to 2 different outputs. Okay, and so we can say that the number 5 has 2 different outputs. So this is not a function. In our last example, 3 goes to 6, 5 goes to 6, 7 goes to 6. That's okay. It's a function because each input has one output. The one output happens to be 6, but each input's different. 3, 5, and 7 are different. That's one input to one output. That is okay. That is a function. Okay. The last thing I want to be able to do is combine all this information together with domain and range. So this should say example 2. Typo on my part. So example 2 says determine if each discrete relation is a function and find the domain and range. So for letter A, I'm going to do my vertical line test to determine if it's a function or not. So if I draw a vertical line, that's okay. That second one's okay, but that third one, we've got 2 different inputs, so that is a no. Okay, how do we know? Well, the number 3 right there has 2 outputs, and it should only have 1. The domain are all the x values and range are all the y values. So for this case, it helps to write out the coordinate pairs. So I'm going to write them out up here. I've got 1, 5, 2, 4. That is my echo, thinking I said echo. 3, 4, 3, 5, 4, 4, and 5, 5. Notice that when we do this, we can see all of my x's and I can see all of my y's. So my domain is all the x's and range is all my y's. Using set, oops, didn't mean to put that in red so we can see it easier. So my domain, use set notation. I've got 1, 2, 3, doesn't repeat, 4 and 5. And my range is all of the y values. Now we have to put the ranges in order from least to greatest. So the lowest range is just 4. Don't repeat the 4. Highest range is 5. So I just have a simple 4, 5 for my range. For letter B, I've got this table. We don't want x to repeat, but here I've got -1 and -1 going to 2 different outputs. So the -1 repeats, so that makes it not a function. How do we know? Because -1 has 2 outputs. My domain are the x values, so my x values are here. And we're going to order them from least to greatest. So my lowest value is -2. Then I've got -1, and then I've got 3 as my x values. Remembering that that -1, we don't list it twice when we do the domain, or the range really. My y values are here. Least to greatest is going to be that -2, then 1, and then 5. Example C is a mapping diagram. Is this relationship a function? Well, notice that 10 just goes to 150, 16 goes to just 240, 17 goes to 240, but remember that 240 is okay because this input has only 1 output. That's okay for y to repeat, so this is a function. And we know that because each input has only 1. Let me write that a little neater. Has only 1 output. its domain, we're going to list the x values. Remember, these are your x's and these are your y's. So my domain is going to be in order from least to greatest, 10, 16, 17, 20. And my y values from least to greatest, 150, 240, and 300. I feel like mapping diagrams have an easier time writing domain and range because they're usually listed in least to greatest already. And finally, what happens when we have a list of coordinate pairs? We sort of already talked about this. Is this relationship a function? I've got one input, one input, one input, one input. So this is a function. And we can say that each x, or input, has only one y. My domain are all those x values, least to greatest. So 1, 2, 3, and 5 that I've underlined in red. And my y values are 3, -7, -7, 7. I need it in least to greatest, so I'm going to list that -7 first, then the 3, then the 7. Reminder that that -7 doesn't get listed twice. So I know this is a lot of information. I know this video is longer than some of the other ones, but this is a really important concept that's going to carry through the whole year. So if you've ever needed help during this video, again, pause, come ask for help, make sure you're taking good notes, and good luck on the practice.